All right, we're back. We're still on page 172, it looks like. And we are going to try to find everything for an ellipse with a given general equation. So all of these problems start with completing the square, and you want to make sure you're right on that. I've been wrong a couple of times. That's always satisfying. So let's see how this goes. So 144 x squared. How many times do I think 144 goes into 864? I'm thinking 6. So like 600 and then 240 and then 24. Yeah, so I'm thinking 6 plus 6x. Leave a gap. Plus 25. How many times do I think that 25 goes into 400? That seems like one I should actually know, so minus 16. I was thinking about quarters. How many quarters are there in $4? There's 16 quarters. I don't know if that's still useful for people, because like quarters don't, I mean, do you run into quarters? Right now there's like a national coin shortage, which I only semi-understand. Plus divide by 2 is 3 squared plus 9. So this will be plus 9. Ah, man, 9 times 144. So what's 9 times 144 is like 36 squared. 3 times 12 and then squared. 36 squared. Do I know that? Is that like 1, 2 something? I don't know. Let's just do 9 times 144. We'll work on that in a second. And then here, divide by 2 squared is 64. 64 times 25. I'm going to try to cheat on this. Try and see what happens. Well, maybe. I don't even know if I can. No, I probably can't. Ah, man. So this will be 144 x plus 3 squared plus 25. So like often it's the case that the number on the other side will just be 144 times 25. Because like when people write the problems, I'm a person who writes problems. When you write the problem, you often just kind of like make it work out for you. What I'm going to do in the background is just use a calculator to speed things along and potentially get it more correct. 9 times 144 plus 64 times 25, 3,600, which is probably, let me see, 144 times 25, 3,600, yes. Okay, so that means that when I'm going to divide everything I see by 3,600, and I'm going to get x plus 3 squared over 25 plus y minus 8 squared over 144 equals 1. So that's number 1. That's my equation. Okay, so since 12 is bigger than 5, it's going to be fat in the y direction, so it might be helpful to just kind of like sketch that. All right, this will be A, B, C. So that can like help you to not mess up. To the center is going to be -3, 8. Vertices. So it's -3 and we're going up and down. So 8 plus or minus 12. Covertices. -3, we're going left and right. So plus or minus 5 and then 8. Foci are going to be -3. We're doing the up and down again. So it's comma 8 plus or minus. I didn't find C. So c squared is a squared minus b squared. And so c squared is 144 minus 25. So c is the square root of 119. Okay, radical 119. Eccentricity is c over a. So radical 119 over 12. And then area is going to be pi times a times b. So 12 times 5. So 60 pi, 7 things, not that bad. The hardest part is completing the square, I think, actually. So once you know what you're doing, it's all just a matter of like moving things in certain directions, plus or minusing. It's not that bad, I think. Are you going to be bad? No, maybe not. So x squared minus 12x plus 4, y squared plus 2y equals -4. All right, divide by 2 and square it, 36. 36. Divide by 2, square it, plus 1. Don't forget, it's really plus 4. X minus 6 squared plus 4. Y plus 1 squared is 36. When we divide by 36, we get x minus 6 squared over 36 plus y plus 1 squared over 9 is 1. And we're good to go. Okay, so you can see that a is going to be 6, b is going to be 3, c squared is 36 minus 9, so c is radical 27. And let's start listing. So that's our equation. So this is fatter in the x direction. All right, so you have your center, you go A, B, C. All right, so center is 6, negative 1. Vertices, that's A in either direction, so 6 plus or minus 6, negative 1. Covertices is B in the other direction, so it's going to be 6 comma negative 1 plus or minus 3. Excuse me. Foci are the same horizontal line as the vertices, so it's going to be 6 plus or minus radical 27. Ew. So remember, if I'm ever going too fast for you, you can slow down the video. If I'm ever going too slowly, you can speed up the video. If you already know what's happening in the video, I guess you can skip it, but you got to take the notes if you're in my class. So I don't know, speed it up to 2x and go for it. Eccentricity, it's going to be c over a, so radical 27 over 6. And it's always good to check and make sure that's less than 1, because for an ellipse, it has to be between 0 and 1. But that's like a very rough check, because you can make a whole lot of mistakes and still get something less than 1. And the area is pi times a times b. So pi times 6 times 3, which is 18 pi. All right, 7 things. There we go. So I'm going to stop this video here, and I will be back in the next one, and we're going to start talking about hyperbolas. So far we know circles and we know ellipses. Hyperbolas are really similar to ellipses, actually. If you have everything down for an ellipse, you're going to be really good to go on a hyperbola. Weirdest part is definitely the graph, but we're going to go over how to graph, so don't worry about that. Anyway, I will see you there.